Welcome to Mr. Brandrick's fourth period class, and we'll be learning about probability.
Yeah, very good. All right. So, in this question, it talks about steroid use in the NFL. All right. Now, I don't know much about it. You know, every once in a while you get a report that comes out that some player tested positive, and usually the player says, "It's not my fault. All right, I didn't do anything." All right, and I always think of Brian Cushing, former Texans linebacker, who one time tested positive. He said, "It wasn't my fault. I just worked out too much." Not sure what that means, but okay. But then he tested positive a second time, and so I don't think that you're telling the truth, Brian. That's okay. He's retired. So let's talk about making a tree. All right, I'm going to pick a color. Ooh, blue. Yeah, let's do blue. I'm going to start my tree.
Wait, a tree with blue?
A tree, a blue tree.
That's not steroids.
The tree's on steroids? What's wrong with steroids? There's not anything wrong with like steroids. I've taken steroids for like sickness, but anabolic steroids are not good for your body. Usually it's some of the steroids that they use in pro sports help regenerate your muscles faster than normal.
But it's not a good one.
It's not allowed. It's called cheating. Yeah. So it's cheating, right? In cycling, in the world of cycling, they do something that allows your blood to cycle faster in your body. So it just helps you feel better the next day when you get on your bike. That's called blood doping. That's cheating. Yeah, like Lance Armstrong, remember he said he didn't do anything? Then he came out and said, yeah, I actually did. Yeah, so anytime you watch cycling, just when you look at them riding, think they're probably cheating. Sadly, that's what cycling has become. All right, so let's talk about the NFL, though. It says that we suppose 5% of current NFL players are using steroids or other performance-enhancing drugs. All right, so I'm going to write down use, and what is 5% as a decimal? 0.05. Now, again, remember, you can go much farther below on your paper, like the bottom half, wherever you want. You can do it much bigger. I know mine's very small right here. So if we think 5% use steroids, what's the likelihood that they don't use steroids? Very good, 95%. So don't use is 95%. Or 0.95. Everybody with me so far? That one. All right, I'm going to switch colors. All right, now I'm going to look at only those players that use steroids. Only those players that use steroids. And it says 1% of players who are using PEDs will test negative. So I'm going to write down negative. Exactly, right? No, but the tests aren't 100% because in American sports, we only use urine tests, urine samples. In international sports, they use blood tests, much easier to see. So that's how. So it doesn't always come out like on the urine test? Yeah, it's not always perfect. There's a margin of error, which we'll talk about next semester. So what percentage of those who use the steroids test negative? 1%, 0.01. So that means if 1% test negative, what's the likelihood that they test positive? Which makes sense, right? I mean, if you're using the drugs, you're probably going to test positive. That makes sense, 0.99. We're only looking at right there, we were only looking at those that took the drugs.
Wait, is this going to be big? Yeah, is this going to be big?
Almost done.
Okay.
I'm done. Now, when I switch colors to orange, favorite color, now I'm looking at those that don't use the drugs. But look at this crazy stat. 3% of players who aren't even using them will test positive. So that means even if they don't use it, there's still a 3% chance that you're going to test positive for using it. So Brian Cushing says, it wasn't me, I didn't do it. A second time. And so I was like, sorry, Brian. So if that means 3% are testing positive, what's the likelihood that if you don't use PEDs, you don't test positive, you test negative? 0.97, which makes sense.
Is that real? Like this?
Sure, these are real numbers. So, I'm going to write down 4 probabilities here. Using and a negative result. Using and a positive result. Not using and a negative result. And then not using and a positive result. So we actually haven't even started to answer any of the questions they want us to answer, because we need to make the tree diagram to find out these 4 probabilities. So to find out these probabilities, we're just going to follow the tree. Okay? So look at the blue one with me. You see where it says 5% use? Everyone see that part of the blue tree?
Yes.
Then I see negative 0.01. If you follow those branches, you're going to multiply 0.05 times 0.01. So what is 0.05 times 0.01? Excellent. 0.005. So we're saying that if I pick a random NFL player, all right, think of your favorite NFL player, which isn't random, but think of an NFL player, they have a 0.005 chance of using steroids and testing negative. So basically cheating and not getting caught. That's what that means. Now, let's look about using and testing positive. So again, we still have the same beginning branch. We're using 0.05, but now we're testing positive 0.99. What's 0.05 times 0.99? Ah, excellent. Yes, calculators will help. Very good. So that's saying the likelihood that a player uses PEDs and tests positive is about 5%. All right.
Wait, that would be multiplied at 0.05 times 0.99.
Correct. Now we're moving into the part of the tree where they're not using the PEDs. So we have they're not using, or they don't use them, 0.95 times our testing negative branch. So that's 0.95 times 0.97. What's 0.95 times 0.97? Very good. 0.9215. So the likelihood that an NFL player does not use drugs, so not cheating, and they test negative, which is what you're hoping for if you're not cheating, is about 92%. Yeah, it's good. It is freaking out over there, Andriana. All right, let's do the last one. Now we're talking about the probability that they don't use PEDs, but they still test positive. What the heck? They're not cheating, but they get caught cheating somehow. What's 0.95 times 0.03? 0.0285. Confirm, anyone?
Yeah.
Confirm. Oh, you missed it. It's 0.95 times 0.03. Now I'll pause here. Make sure we all still feel good. Everyone feel okay? Yes, Kayla. Don't use and not use. Sorry, I know I switched it, but don't use and not use are the same. Oh, blue, don't use.
Oh, I was gonna say positive.
Well, so this is negative and this one's positive. So take the phone call, sure. Now, whenever I finish this part of the tree diagram, because we finished, I always make sure that my probabilities, in this case there's 4 of them, won't always be 4, but the probabilities I wrote should add up to 1. Very good, Kayla. So take 10 seconds, confirm that 0.005, 0.0495, 0.9215, 0.0285 add to 1.
get from
Uh-oh.
1.0045.
Ooh. Did we do something wrong? Did they add a 1? Over 1?
Yeah.
Interesting.
Interesting. Did we do all these right?
Yeah.
Yes? Double check those.
First one you put another 0.
Ah!
Huh?
Try that.
I thought I did that wrong. Whatever I added with the first one.
Thank you, Jace. Now let's see if it's right. See, I'm glad we checked because I made a mistake. Now it's 1. All right. Now that it's 1, we're ready to answer number 1. It says, what's the probability that a randomly selected player will test positive for performance-enhancing drugs? So look at your 4 probabilities. Do any of those 4 say they test positive? Which ones?
4.95.
Right? Plus? Excellent. Whatever that is our answer.
So we created another tree just to get that?
Oh, we're going to do number 2 as well. And it might be a little tree, but it had a lot of big numbers. And by big, I mean important. What is it, Kayla? 0.071? Isn't it 0.078?
Yeah.
Oh, here, you guys are thinking that's a 1. That's an 8 there. 8, 5.
Oh.
So 0.078. Great, we finished the first one. The second one says, if you randomly select a player who tests positive. So right now there's alarm bells going off in my head that says that is a what? What did they just tell me there? A condition. Very good. That's a given. So I'm going to write down the probability of something given that they test positive. So if I tell you they test positive, what's the likelihood that they actually use the steroids? Does everyone see that? Now here's how the formula works. And this is the formula you're going to be given. Whenever you do a conditional, whatever comes after the bar is the condition. That goes in the denominator. Always. So the probability that they test positive goes in the denominator. Now what goes in the numerator? Which is what everyone says, but here's actually what it actually should be. It is used, but what do you know already happened?
It's positive.
They tested positive. So that's why it's used and positive. Every time, this is how it will work. And this formula will be given to you. Obviously, it won't say use and positive. It'll say A and B. So this will be probability B, A, and B. All right, now we should know all of that, don't we? What's the probability that they test positive? Very good, 0.078. We just found that in number 1. And what is the probability that they use PEDs and they test positive? Divide those, and you'll get your answer. That's right. Excellent. Are there any questions for me? You will have to do this on the quiz next Thursday. I guess this coming Thursday. Tree diagram and all. So the tree diagram is only for certain type of problems. And I'm going to, hopefully before Thursday, help you understand when you should use the tree diagram. All right? So what I would say is, obviously it's challenging to do all this work. I understand that. But probably more so is just knowing when to do it. All right? So right now, go ahead and flip the page over. You should see quiz A. And read number 2. Read number 2. Read number 2.
Oh, goodbye.
Goodbye. Don't forget to like, subscribe, and hit the bell so you get alerts when I post new videos. Right, 3 more subscribers. You got it.